For this experiment, I have here two small magnets. I'm going to drop them both at the same time so you see they're exactly alike in both size and weight. Now I'll let one fall freely, while the other will fall through a copper tube. Which one do you think will fall faster? Well, before you answer, keep in mind that the diameter of the tube is wide enough to allow the magnet to fall through without touching the sides. And also, as we know, magnets aren't attracted to copper. So, which magnet will reach the table first? Place your bets now. So, why did this magnet arrive long after this magnet? Well, in this demonstration, as the magnet moves through the tube, the flux changes. This induces electromotive force. Because of the shape of the tube, we get circular currents. They're called eddy currents. Lenz's law tells us that these eddy currents will generate a magnetic force that opposes the movement of the falling magnet. Can we measure these invisible eddy currents? Well, for this we will use the Novalink and the 2.5 ampere current sensor, along with this special apparatus. This is a plastic tube with a solenoid inserted in the center. First, let's set up the equipment by connecting the sensor to the Novalink and to the apparatus. We can now program the data logger using the Multilab software. We're going to choose a rate of 500 samples per second and a sampling time of 20 seconds. Now, let's place the magnet inside the tube by simply opening the top, inserting the magnet, and closing. We're now ready to start collecting data. Before we do that, click Run and start shaking the magnet, as so. And one more. All right. Now, let's take a look at our results. Every time the magnet crosses the solenoid, we first get a spike down and then a spike up in the graph. The change we see in the direction of the spikes reflects the change in the direction of the currents. The results we got are in complete accordance with Lenz's law. And here's something really cool. Check out how the magnet falls through the tube. Magnetizing.